I observed the following stages in flight. My start point is the stretched bungee with the glider ready to launch. Then the glider launches. As it goes, it climbs, slowing slightly as it climbs, and then from the peak of its flight it descends and speeds up a little. Then it touches down. When it touches down, it slows rapidly, so my end point is the glider has stopped. So I've shown them on this picture here across the top so that we can see what happens. And down at the bottom you'll see I've got a key. I've coloured the different energy stores different colours. So here we go with stretching the bungee, and the bungee stores elastic potential energy. And I must have used my own internal energy to stretch the bungee in the first place. So we're ready to launch. And at the point that we launch, the bungee transfers its elastic potential energy to the glider as kinetic energy. The glider moves forward. The glider also climbs, and as it climbs, it's converting some of its kinetic energy to gravitational potential energy. It's higher than it started. But at the same time, you see we've got environment here, because air resistance means that the glider transfers energy to the surrounding air. It moves it a little and it heats it a little. So it's transferring energy as internal energy and kinetic energy. And that's going to happen all the time the glider is flying. So the glider gets to the peak of its flight, then it starts to descend, and it then transfers its gravitational potential energy back to kinetic energy. And it continues to transfer kinetic and internal energy back to the environment. At the point that it gets down to ground level, it's got no gravitational potential energy stored compared to where it started, just the same amount, so that's all been transferred into kinetic energy or transferred to the environment around it. And of course, once it's touched down, the glider's remaining kinetic energy is transferred pretty quickly via friction. It slows down and it stops. So it's transferred through friction to the ground as internal energy. And that's my end point. So we think of it just watching the glider as the energy being lost as it stops, but conservation energy means that the glider's energy hasn't been lost. It's actually all been transferred to the environment, but it's spread out enough that it would be really difficult to measure. And this transfer is the reason that gliders descend all the time unless they are finding rising air to circle and climb in, and it's the reason that powered aeroplanes need to use their engine to counteract that and maintain their height.